Okay, good day everyone. This is Matt with BigBen. So we have the third question on the differential equation of second order, having a particular on the right hand side. You know, um, the system goes by obtaining y is equals to yh plus yp, where yh is the homogeneous part of the question, and the yp represents the particular part of the question. Okay, so yh for the homogeneous, you know, intends that we have to equate the left hand side equals to 0, using either the d operator or the m operator. Y for the y particular here, depending on the nature of the particular given. So here we have it to be 2 x exponential of x, so it comes in form of an exponential. That is for the y particular. Okay, so now let's get our characteristics equation, otherwise known as the auxiliary equation. So it becomes, using the m operator, we have m squared minus 3m plus 2 equals to 0. Okay, so now solving quadratically, I end up having that my m1 equals to 2 or my m2 equals to 1. Okay, so for the y homogeneous, I have that yh equals to c1 exponential m1x plus c2 exponential m2x, where this m1 and m2 are the roots of the quadratic equation. Is that taken? That's beautiful. So now, substituting the value of my m1, m2 into this, I have it to be 2 and 1. 1 times x is x, that is why the 1 didn't appear here. Is that taken? Okay, good and fine. So guys, let me call this one equation asterisk. Good. So this equation asterisk becomes my homogeneous part. This is my y homogeneous for the question above. Okay, so now guys, let's continue. Then I needed to obtain to get my yp. Now, because of the presence of this x here, my yp for the particular part becomes ax exponential of x plus b exponential of x. Okay, so but guys, let's do something. Let's check up something here. Now, if you observe critically here, actually you see we would have talked about this very term here if we had gotten probably same roots where we differentiate maybe by putting x here. Okay, but since we don't have that here, now coming over to this place now, guys, if we see something is happening here. Here we have c2, here we have b, for instance, and they are both constant. We have exponential of x, and so they look alike. So we don't want anything of the same nature. So what do we do next is to modify. So by modification, guys, we have to multiply everything on this initial particular by x. Okay, so we can have difference from the y homogeneous. Okay, because the y homogeneous shouldn't be carrying the same characteristics with the y particular. All right, so now let's fire on. So by modification, multiplying the particular by x, I have ax. Now when x multiply here, I have ax. Okay, ax here, and ax squared exponential of x plus bx ex. Okay, so this is why I have here equation 2. So guys, this becomes my y particular. That is for yp. Okay, so guys, differentiating this one now, I believe this is clear. Okay, so let me explain a gas code. So differentiating equation 2, now bringing out this constant here, which is a. Outside I have this. Now I have to differentiate this term here, guys. I have to differentiate this term here using product rule. Okay, so here I kept exponential of e constant, multiply. Now differentiate x squared, which is 2x plus. So here keeping this constant. Okay, I have this exactly. So differentiating this one using product rule, I kept this constant. Differentiating this one, I have this plus. Okay, I kept this constant. Differentiating this, I still have this. Now going over to this place, I have b. So the b is out because it's the constant. So guys, if you observe critically here, I can still differentiate this one using product rule. Okay, now where I make one my u, then the other one my v, v dx. Okay, and so on and so forth. So I have here to be b. Now if we differentiate this one using product rule, this is what I obtain here, which is x, ex. Okay, now That is how it is. So now guys, next is to expand this very equation here. So using a to multiply everything, I have the same thing. Using b to multiply everything, I have the same thing. So this becomes my yp prime, and this gives me equation 3, guys. Okay, so that is fine. Equation 3. Okay, now let's continue. So from the equation 3, I have to still differentiate this very term here in order to get my second order, that is d square y over dx square. So guys, now this becomes, now I have to factor out the constant, differentiating only this one using product rule. I have this, I have a here, differentiating this one using product rule, I still have this, guys. Now for my b, okay, so for b, guys, I have differentiating this one using product rule, I have this, then this is just, the same thing. Okay, this is just the same thing. Now so let's continue, guys. So from here, this becomes, I have this, if when I expand using, when I expand, I end up having equation 4, as per se. This is equation 3, 4, and 2. So now, guys, I'm substituting equation 2, equation 3, and equation 4 into equation 1, as earlier stated. Okay, I'm substituting it, on the on the homogeneous aspect, so that I can be able to equate it with the particular aspect of the very question. So now doing that, this is a whole lot of what it entails. Okay, now sorry I couldn't use my whiteboard because it wouldn't contain, it's very small. So I have this, this is all that I've got. So let me equate here, guys, to equals to 2x ex. Okay, so this is what I have on it. All right, so guys, let's continue. I have this to be this. Now having expanded, I got everything to be this. So lastly, if you observe very well, you just make the common mathematics there. So if you watch here, this is 4axe, I have here to be 6axe. So this and this one here, this one here, and this one here, definitely, guys, will definitely give me minus 2axex. All right, and I ended up having here to be minus bex. Okay, all right. So lastly, guys, here bringing out the coefficients of 2axex, I have a plus b equals to 1, and here I have 2a plus b equals to 0. Okay, so simultaneously this guy, a is equals to 1 and b is equals to minus 2. So my y particular, remember guys, I said my y particular, this from equation 2 is my y particular. Okay, where I have ax square ex plus bx ex. So having done this, guys, you see I now have it to be, substituting the value of a and b, I have minus s square ex minus 2x e. Okay, so I now have it finally that my y is equals to y homogeneous plus y particular. So as stated earlier in the question, this is my y homogeneous, this is my y homogeneous, guys, this one. So look at it here too. Okay, and my y particular, as earlier gotten lately, this is it here. So this is my y particular. So guys, this very answer here is the question to the second order differential equation we just solved. So this is the question, this is the answer to this very question here. Okay, so this is how it is. Okay, so guys, I hope this question meets you guys very well, and please do me well to subscribe to my YouTube channel, so I believe you'll be able to capture each and every part of the question. Okay, so thank you.